Pengetahuan dan Ilmu Universitas 11 Maret, Dr. Imam Sujadi, MSI, yang terhormat Wakil Dekan Bidang Akademik dan Penelitian FKIP UNS, Prof. Dr. Pait Nur Mayunita Indriyanti, SPD, MSI, MSc, yang terhormat Ibu Ketua Program Studi Pendidikan Matematika, UNS, Dr. Farida Nur Hasanah, MSI, dan yang terhormat The Honorable Dr. Guillermo Bautista selaku narasumber dalam webinar kita hari ini, dan juga tidak lupa para peserta webinar yang berbahagia dimanapun Bapak dan Ibu berada. Puji dan syukur marilah kita panjatkan kehadirat Tuhan Yang Maha Esa, karena atas limpahan rahmat, taufik serta hidayahnya, kita semua diberikan nikmat, sehat, dan kesempatan untuk dapat berkumpul bersama dalam ruang virtual webinar series yang diselenggarakan oleh Magister Pendidikan Matematika Universitas 11 Maret. Selawat serta salam semoga senantiasa tercurah kepada junjungan kita, Nabi Agung Muhammad SAW, beserta keluarganya dan para sahabat, dan semoga kita semua mendapatkan syafaatnya di hari akhir kelak. Amin ya rabbal alamin. Perkenalkan, saya Sayyidina Nafisa Asmi, yang pada kesempatan ini akan memandu jalannya acara webinar kita. Semoga rangkaian kegiatan hari ini dapat berjalan dengan lancar dan memberikan manfaat bagi kita semua. Hadirin yang terhormat, sebelum kita memulai seluruh rangkaian acara pada hari ini, marilah kita bersama-sama mendengarkan dan mengikuti lagu kebangsaan kita, Indonesia Raya, dengan hikmat. Kepada seluruh peserta, dipersilakan untuk mengambil posisi duduk siap dan menonaktifkan mikrofon masing-masing. Okay, thank you. May that national anthem further strengthen our sense of national pride and our enthusiasm for learning this afternoon. Next, the program will continue with remarks from the head of the Master Program in Mathematics Education, Universitas 11 Maret, Dr. Farida Nur Hasanah, MSc. Kepada Dr. Farida, the floor and time is yours now.
Thank you very much, Mbak Sasa. Terima kasih. Apakah suara saya sudah bisa terdengar? Oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, the Honorable Dean of Faculty of Teacher Training and Education, which is represented by our Vice Dean for Academic Affairs, Academic and Research Affairs, Professor Nurma Yunita Indriyanti. The Honorable, of course, our keynote speaker, Dr. Guillermo Bautista, respected colleges, lecturers, students, teachers, and participants who are joining us from various institutions and countries. On behalf of the Master Program in Mathematics Education, Faculty of Teacher Training and Education, 11 Maret University, it is my great pleasure to welcome all of you on today's international webinar with the theme of optimizing GeoGebra for STEM education in mathematics learning. We are truly honored. Today we have with us Dr. Guillermo Bautista from UNS University. Yeah, actually, our department has a long history with UNS University in Austria, with Professor Zold and then many others experts from Linz. Today, we sincerely appreciate your willingness to share your expertise and experience with us, yeah, despite, of course, your busy schedule. And today, Dr. Guillermo will deliver very interesting presentation, which is also in line with the curriculum of our department. So in Master Education, Plasma University in Mathematics Education, we are focusing on interdisciplinary mathematics education. Yeah, the title of his presentation today is a function art, linking mathematics, art, and technology. So this is very relevant. The integration of technology, of course, into mathematics education continue to open new opportunities for creating meaningful, engaging, and interdisciplinary experience. In this regard, we already know the GeoGebra has become one of the most powerful tools for supporting exploration, visualization, creativity, and problem solving in geometry, algebra, even statistics. So it is very famous applications, web-based application in mathematics. When we combine GeoGebra with the STEM approach, of course, it will provide even greater potential to connect mathematics with science, technology, engineering, and arts in the very authentic learning context. And therefore, today's webinar is a valuable opportunity for all of us, educators, researchers, as well as students, to gain new insight into how GeoGebra can be optimized to enrich mathematics learning and support innovative educational practices. So for your information, actually, almost in our classroom, in our faculty and mathematics education department, we introduced the GeoGebra in geometry classroom and calculus. Yeah, so I think it is very valuable experience for our students also. I would like also to express my gratitude to all participants for your enthusiasm and commitment to continuous professional learning to join this event. Your presence reflects that our shared dedication to improving mathematics education in the digital era. So in this occasion, I humbly ask the Vice Dean for the Academic and Research Affairs for officially open this event. Okay, without further ado, I wish all of us has a productive and inspiring session. May today's discussion lead to new ideas, collaboration, and innovation in mathematics education. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you for those inspiring remarks, Dr. Farida. May the hopes and the enthusiasm that you have shared serve as motivation for us all. So next, we highly welcome to the Vice Dean of Academic and Research of FKIP UNS to deliver her remarks and officially open our webinar to the Honorable Professor Nur Mayunita Indrianti. The floor and time is yours.
Yes, thank you very much, Mbak Saida. Okay, can you hear my voice clearly? Okay, yes, thank you. Good afternoon for all of you in Indonesia and good morning for our speaker, Dr. Guillermo Bautista from University of Linz, Austria, and also for all of you. Yeah, the Honorable, the speaker of today's webinar, Professor Dr. Guillermo Bautista from University of Linz, Austria, and then the Honorable, the Head of Study Program of Mathematics Education in Master Program, Ibu Dr. Farida Nur Hasana, and also the Honorable all of the lecturers in the department, and then the participant, yeah, from UNS or from other institution. Yes, this is the great pleasure to welcome you all to this webinar series that held by Master Program of Mathematics Education in our Faculty of Teacher Training Education, Universitas 11 Maret. And I saw from Bu Farida's report also that Mathematics also had previous webinar, yeah, regarding the title that already also performed in your presentation. And also today we have a special theme that would have function art linking mathematics, art, and also technology. And this is as optimizing GeoGebra, yeah, in STEAM education for mathematics learning. Yes, on behalf of the faculty, we would like to express our sincere appreciation for the speakers today, Dr. Bautista, and also participants who have taken the time to join us today in this webinar series. And when we talk about mathematics, yeah, the rapid changes of 21st century learning challenge us to rethink about how mathematics taught and also learned at school, at higher institution as well. From the beginning, when a student or our children at home studied mathematics, the impression is of course not so make the best impression from them. But mathematics is no longer merely about numbers and formulas. We should affirm this. It is about nurturing creativity, yeah, in STEM, critical thinking, problem solving, and of course innovation itself. And when we regard to GeoGebra and part of the strengthening STEM education, so how integrate the mathematics, technology, and arts, yes, offer valuable opportunities to make mathematics learning more meaningful, mindful, and also joyful for students at school. And then, of course, through this webinar series, we hope we create more collaboration from educators, from researchers, from maybe we have also teachers here, Bu Ida. The practitioner can exchange the ideas, have the discussion, practices, and also explore innovative strategies to strengthening STEM education here in Indonesia. And in our Faculty of Teacher Training Education, we also have a STEAM Center. Yeah, this is as part of the one of the unit in front of the faculty that support us to have the STEM education is more engageful in all of the in the level in higher education as well as in secondary school. And the last thing, I would like to extend my heartfelt gratitude to speakers that you give time opportunities to sharing your expertise and also your experiences in research, in learning there in Linz University. And also, I also thank the organizing committee, the study program, for the hard work to make this event can be conducted. And we know here that there more than 100 participants join us today. Yeah, by saying Bismillahirrahmanirrahim, I officially open this webinar series in the theme of function art, linking mathematics, art, and technology that help by Master Program of Mathematics Education in FTTE. Thank you very much. Enjoy the webinar for all of you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Dr. Pait Nurma Yunita Indrianti for her warm remarks and for officially opening this event. So with the event now officially open, we will move directly into the core session of the webinar. So ladies and gentlemen, before we proceed to the main sessions, let us capture this afternoon's moment with a group photo sessions. So we kindly request all the participants, including our Vice Dean and everyone, to turn on your camera and give your best smile. So the committee will help to take the screenshot across the several side. Bapak Ibu bisa dibuka kameranya dulu. Satu, dua, tiga. Next slide. 1, 2, 3. Next slide. 1, 2, 3. Okay. Thank you so much, everyone. So, as I mentioned at the start at the event, in addition to guiding the opening as MC, I will also be serving directly as the moderator who will guide the presentation session and the interactive discussion until the end of the event. With that, let us move straight into the core session that we all been looking forward to this afternoon. So, ladies and gentlemen, and distinguished guests and fellow educators, we are now entering the main session of our webinar. As the moderator, I am absolutely delighted to lead these insightful discussions. Today, we are going to explore a very fascinating topic, function art linking mathematics, art, and technology, with a special focus on optimizing GeoGebra for STEAM education. Before we welcome to our speaker, please allow me to read his distinguished profile. So, our speaker today is an internationally recognized expert in mathematics education, Dr. Guillermo Bautista. So, Dr. Guillermo Bautista is a mathematics education specialist at the University of the Philippines National Institute for Science and Mathematics Education Development, and also a researcher at the Johannes Kepler University, Austria. He has more than 2 decades of experience in training teachers and developing curriculum materials from elementary school to the university level, focusing on the integration of technology in the teaching and learning of mathematics. Dr. Bautista also has been training educators, teachers, and students around the world in the use of GeoGebra for teaching and learning mathematics since 2006. In 2012, he was recognized as the first GeoGebra ambassador of the International GeoGebra Institute. He led the establishment of the GeoGebra Institute of Manila and has been one of the pioneers in integrating GeoGebra into mathematics education in Philippines. Dr. Batista graduated from PhD in STEAM education at Johannes Kepler University in Linz, Austria. His research focused on integrating art, technology, and mathematics through GeoGebra in the form of function art. So the function art refers to artistic creations that use graph of mathematical function. His research also on function art has been published in Q1 journals. During his PhD, Mr. Bautista has worked as GeoGebra expert in various European projects. He has also supported PhD students in their GeoGebra-related project, including the development of research materials, teacher training, and the facilitation of seminar and workshop. It is true honor and privilege to have him with us today. So, good afternoon, Dr. Bautista.
Okay, so good afternoon, everyone, and good afternoon to all the distinguished guests also and the participants. Forgive me if I pronounce your name, Professor Norma Yunita and Professor Farida also, and Miss Saida for hosting the event for moderating. So, can I start now? May I?
Yes, sir.
Okay, so all right. So I only have 1 hour, so I cannot really dig deep into the research. But basically, function art is the my PhD here at the Johannes Kepler University. I just graduated PhD last month, and this was my project. No, I think this is still my project until of course the probably in the foreseeable future. So I won't do full screen because I think you can still see my screen, and so I can switch easily. So this is the workshop outline. Workshop in a sense that hopefully I'll give you a little bit of time to also explore. No? So this is what's going to happen. A bit of introduction to GeoGebra, but I think many of you already know GeoGebra, so we don't really spend a lot of time on that. The GeoGebra interface and resources, graph entry. We learn how to graph, and again, I think a lot of you already know, but just in case someone who is not familiar, we have a little bit of hands-on overview of the artwork. We have transformation of functions, and so on and so forth. So you might be wondering, why is this the outline of the talk? No? And this is the outline of the talk because this is actually what I did in my study, and many students just follow this 2 hour outline, and they were able to create beautiful artworks. And later I will see you. I will show you some of them. There are hundreds of them, but I will show you some, and later I'll also show you where I posted. Okay, so let's start. So what is GeoGebra? So it's again, I think it was mentioned earlier that it's a dynamic mathematics software for teaching and learning mathematics, and that combines algebra, geometry, calculus, statistics, spreadsheet in one package. So recently, GeoGebra has expanded into 3D, for example. So 3D modeling and 3D printing. So it is a very, very powerful software, and you can do a lot of things in GeoGebra. Okay, so these are only some of the applets that I created. So, but this one was created by a student. So the GeoGebra interface, you can see, I can put it in the chat in case I can put the link in the chat in case you want to explore. So when you open GeoGebra on the web or you download it, there are many versions, but I usually use the classic version because it's the most complete. No? So you can just choose here what do you want to do. So you can have graphing, you can have 3D graphics, you can have CAS, you can have spreadsheets, and so on. So basically, this is what I use, the classic. And you can see here the tools, no? And also the input bar. So this is where you type your equations. For example, f of x equals x squared, for example. So you just type it there. And you also have the square, the tools here where you can draw different shapes, no? And different geometric objects like circle, for example, and you can draw polygons, and so on and so forth. Again, this is just an overview for those who are not familiar, but I think many of you already know GeoGebra, so you can draw lines, for example. And as you can see, while you are drawing here, you can also see the geometric, you can see the geometric object, and also you can see the algebraic equivalent here. So this is really good for multiple representations because the students see different representations at the same time. So this is very good for exploration. Okay, so this is GeoGebra. You have the calculator. So I cannot see it from my screen, but it's supposed to be somewhere here. So if you click here, you can see the calculator. This is the keyboard that looks like a keyboard icon. And if you click on that, you can see the calculator here. Okay. So you can have the symbols, for example, for calculations, you can have even the Greek letters and all the symbols, mathematical symbols. Well, at least mostly the ones that we mostly use. Okay, so this is the environment. I don't know if You know this guy? This is Marcus, actually. He's a professor here at JKU, and he is the one who
The
created
designer.
GeoGebra.
Yes,
Yeah,
the
yeah.
designer.
Yeah, yes. So he's the one who actually created GeoGebra. So he is a professor. He's my boss here at the at JKU. So the graphics view I've showed you earlier, and then the perspective, so you can have different perspectives here. You have the style bar. So for example, here, style bar is you can change the color, for example, of the object. You can change the style. You can say change the size, for example. So if you want it to be thicker, or for if you're clicking on a point, of course, you will have a slightly different properties or styles. Like you can have different point styles, for example, depending on what you want. Okay. So this is very easy for the students to explore. They can, I think students, especially in high schools, for those of you who are teaching in high school, they are very they like to explore, so they can explore this. And for creating function art, we teach the students, of course. This is the third slide. This is what I teach them when I give the webinar. So just basic graphing. For example, how do you graph x squared, x cubed, sine x? And you can also have the inequality, and you can also have the conics, for example, circles, for example. So let's try some examples. Also, not this one. So let me just refresh to have a new window. So you can, for example, type f of x equals x squared. We have done that already. And also g of x equals x cubed. You can also do some inequalities. So for example, y is less than x, for example. So you can have inequalities. And you can also type the equations of circles. For example, x minus 2 squared plus y plus 3 squared equals 1. Okay, so you can create circles, and of course other conics as well, as if the students know the equations. Okay, so they can also do, of course, they can also try this sine x. Just type y equals sine and then parenthesis x. Maybe we do it. I think this is recorded, right? Dr. Faride,
Yes,
this is
yes.
recorded?
Yes,
Yeah,
it is. We recorded
yeah,
this. No worries.
yes, thank you. So it's a bit fast, but you can come back to it later because we don't have a lot of time. It's a bit fast, but hopefully you can catch up later by watching again the video. So after introducing graphing to the students, what I do is I let them see that we will do this. No, I'm sorry about this apologo, but this is a long story because at that time I didn't have. I was invited. The history of this apologo is I was invited in a talk, and they want me to talk about it. Like 2 days after, I didn't have the time to prepare. They want me to talk about the integration of arts and mathematics, and I have this drawing in GeoGebra, and I just didn't have the time to prepare, so I just choose this, and ever since in my project I just choose this. Anyway, this is copyright free. I checked the image itself, so it's fine if the students do it. So I just show them that this is what we're going to do. But first, we must review transformational functions. And the reason why we have this review for transformation of functions is because in the Philippines, I did my project in the Philippines, we didn't have a specific topic on transformation of functions. Like it's distributed across the curriculum, but there is really no chapter at that time. Like when I did the project 3 years ago, but now we have that in the curriculum, so probably there's no need to do this. But at that time, I did this because they they the students probably doesn't know it. So I just to have a brief review. So just type sin x, for example. I asked them to type sin x, and then this is during the webinar. So I do it. I do the lecture also like this, and then let them type sin x plus 2, and then let them observe what is the relationship between this or among these graphs. No, so we are teachers, so we definitely know this. The students will observe that when you add 2, the graph actually goes up by 2 units, right? And when you subtract 3, it goes down by 3 units. So let's have a little bit of an example. So the students will observe that. I ask them. So in the webinar, they spend like 5 minutes for this. The webinar takes like 2 hours, 2.5. So they type this on their own. And then what happens, for example, if we add 2? No? So they see that the relationship is that if you add 2, it's actually moving up by 2 units. And if you subtract 3, it actually goes down by 3 units. And then after that, we have a little bit of discussion, and I ask them if they try other functions as well, if the observation is the same. And after that, we have a generalization, no? So that if you add a positive number to the output value, the f of x, then it goes up. It translates its graph by that number of unit, and subtracting or adding the negative translates its graph down by that number of unit. No, so the students observe this and they make a generalization. So hopefully they understand. No, of course, cannot really claim, but we are hoping that they understand. Okay, so let me just take a screenshot of this. Okay, so after that, there is another transformation this time. That the first one is the vertical translation, introduce the term. And then the second one is I also asked them again to graph these 3 and observe the difference. No, so I put the colors so it's easy for them to see the changes, so they can see that all the x's from P of x became x plus 1. So they observe that when they add 1, actually, when you graph, it moves the graph 2 units, 1 unit but to the left, and when you subtract 4, it moves by 4 units to the right. No? So this is what the students observe. So I will demo it again, and then for the other 2 later, I think we don't have to demo it. So P of x equals x squared plus 3x. P of x equals x squared plus 3x. And then we have Q of x. So all the x's becomes x plus 1. So this becomes x plus 1 squared. And then plus 3 times quantity x plus 1. So the students will observe that, oh, this is actually a movement to the left by 1 unit. And if you subtract x minus 4 quantity squared plus 3 times quantity x minus 4. So if you subtract 4, it actually moves to the right by 4 units. No? So these students, they of course some of them know, but some of them they are not very good at math. So they are like they at least they observe something and they make conjectures about their observation and they generalize, of course. And again, same discussion. So we discuss a bit during the webinar, and then again they try it on other functions, and they observe that when you add a positive number to the input that is in the x, translate the graph uh, to the left, and adding a negative. Adding a negative means subtraction, right? Adding a negative number becomes translates the graph to the right. Okay, so they must know these concepts to be able to do function art, because they use graphs, no? So to do function art, they have to use graphs of mathematical functions in creating their artwork. And then after that, there are two more transformations. These are very similar patterns. So they type, and then they observe what happens. So this is for vertical scaling and for horizontal scaling also. So they also do that. Okay. So I don't really need to I think to explain a lot because we are all teachers, so we already know this. And then here we at the summary, we try to summarize and differentiate what do you mean by adding the number to the to the output and the input. So we have to differentiate what do we mean by the input. So the output is actually the function itself, 5x squared plus 8x, and the input is x. So that is the difference between adding to the output. The output is 5x squared plus 8x, adding 3, versus adding to the input, right? So here we add to the input by 3, so we are actually adding to the 3, not to the function itself, to x. So this is very important because many students will get confused by what do you mean by adding to the input and adding to the output. Okay. And also similar with the scaling, vertical and horizontal scaling. So how do you mean? What do you mean by multiplying to the input and multiplying by the output? So the output is 5x squared plus 8x. So if you say you multiply the output, you multiply the entire expression. And when you multiply the input, you multiply all the x's. Okay. And at the end, we summarize, no? I summarize these translations and scaling, but you notice that I didn't discuss reflection. So the reason for this is because it's going to be very long. The seminar is again 2.5 hours, usually when I do this with the students. And by the way, I do this directly with the students. So it's not that I give seminar to the teacher and then the teacher does it. Well, in some cases, I worked with many teachers. So in some cases, the teachers don't want to do it. Like they are not very confident, and they just say, "Oh, just do it yourself." And in some cases, the teachers are confident and they say, "Oh, I can do it. I can do this now. Just give me the PowerPoint." No, so I just give them the PowerPoint and they do it themselves. Okay. Any questions? Right. So the students know how to graph at this point, and then the students also have an idea. No? Maybe they have an idea of transformations. No? And the question now is, how do you limit the domain of the graph now? So you want to cut the graph, right? Because if you type x squared, it's forever going up, forever going to the right, and forever going to the left. No, so the domain is set of real numbers. So it's important for them to create their artwork. They have to cut the functions, no, to cut the graph. So this is where we teach them. So if you go to GeoGebra, so if you go to GeoGebra, if you type, for example, X, let's delete this. You can hide, by the way. So you can either hide or delete. But if you don't need the object, better delete, because it also drains the memory of your computer. And also, if you have a lot of objects, the loading will be very slow. No? But we have only two, so it's fine. So if you want to cut, for example, from -2 to 1, no? So for example, you only want this arc, for example. So you can just have your function p of x squared plus 3x, and then you type comma, and then what is your domain? So my domain, for example, is from -2, from -2, for example, and then to 1, for example. So you can do that. Okay. So the familiar. All right. So this is cutting. So you are familiar probably, right? So another strategy that this came later in the my study took 3 years, so I had a lot of implementations, and also they the students asked how to color. So it's actually easy to color using if you use the inequality. So for example, we have these two equations, f of x equals x squared minus 3. And then and then what if I want to color the region in between? I can just say y is between f of x and then g of x. So the students later in my project, I already taught this to the students because a lot of them are asking about it. Okay. All right. So now, how to create artwork? This is the most exciting part. All right. So the reason why I told you what happened in the seminar, because I want you to know what the students know before they create the artwork. No. So in my seminar, in my webinar, I teach them how to create this logo using what they have learned before. So for example, let's go to the logo. This is already the artwork. So the students will insert the image. There are two ways to do it. One is, I think the easiest way, and many of the students do it. They draw first using pencil and paper, using tablet, or maybe sometimes they ask, they get the image from the internet and then insert it. So to insert an image is just attaching an email. So for example, here you can have the image here, okay, and then you can browse and then get an image from your computer, and then maybe I take a screenshot first here so that I can show you exactly how to do it. Okay, so for example, you have an image. I've already taken a screenshot. You have an image, for example, and then you browse, and then I can take that screenshot and I have the image here. And then I can use these 2 points to, position the image that I have. Okay. So for example, I want to position it here, or something like that. And then when you are done, you can just hide the point so you don't have to, or if you want, you can fix the image so you don't accidentally, if you lock, you cannot drag it. So you cannot drag it. And you can, of course, unlock if you want to change it again. Okay. So once the image is there, you of course you have to have the axis to estimate it. So my question to you is, based on what the students learn, so I'm going to give you like 5 minutes to maybe draw one of the curves here using functions. And maybe some of you can volunteer and give me the equation. So 5 minutes just to have a bit of hands-on. We don't have a lot of time. So I give you the link and then try to estimate here. You can use any functions that you know. Maybe one of the curves here. And then later on, I will tell you how I teach the students to do it based on what they learn. So I'll give you the link and then maybe I'll ask for some volunteers later to give the equation and let's see. So you have to give the equation and the interval. So just like what we learned earlier. So you have to cut the function. Right? So 5 minutes. And then let's see. Maybe I'll have two volunteers later to you can tell me the equation and then we can type here and also we can just to have a feel of what the students do. Okay, so it's 9:50 here, 9:55. I'll ask for two volunteers if there are.
Oke, baik para peserta, bisa yang mau volunteer untuk menyumbangkan idenya untuk equations atau perhitungannya bisa ditaruh di kolom chat, nanti dipanggil sama Bapak Dokter. Nah, teman-teman ada yang mau menyumbangkan idenya untuk perhitungan fungsi? Silahkan ditaruh di kolom komentar untuk berbagi ide kreativitasnya. Waktu cuma 5 menit ya. Oke, satu lagi ada nggak? Satu lagi untuk menyumbangkan idenya.
All right, so we have some volunteers here, private message. We have f of x equals x squared plus 1/2. Let's see, f of x equals x squared plus 1/2. Oh, negative 1/8, sorry, negative 1/8, negative 1/8. Okay, x squared plus 1/2. Okay, so that estimates it. And then there's another one, x plus 1, x quantity x plus 1 squared plus y squared plus 4. 4. Is it correct? X plus 1 squared, or x, is it x minus 1? X minus 1 squared plus y squared. Not quite. Okay, so but my point is, this is what the students do when they create their artwork. So they estimate, but for them to be able to estimate, they have to know, of course, the functions and the other objects. So this is what I see, what I do. No, I will do now what I do with the students. So I will ask the students, let's estimate this part here. It looks like a quadratic function. And then I will start just to scaffold the learning, what they have learned earlier about transformation. That's why I needed to show you. So suppose I start from 5 f of x equals x squared, for example. Now I want to do is I want to translate. So they already know the word translation. I want to translate this here. No? I want the vertex to be at -2. So what should I change with the x squared? Is it x squared plus 2? Is it x squared minus 2? Or is it x minus 2 squared? Or is it x plus 2 quantity squared? So maybe some of them, since they already know, they know that it should be x minus 2 if I want to move to the left squared, or x plus 2, sorry. So it's not very, for the translation, for the horizontal translation, it's not very intuitive because it's always the opposite. So if you add 2, it goes to the left, and if you subtract 2, it goes to the right. No, and then I can tell them, oh, so this is correct here, but we have to move this down, right? Move this down a little bit, and they have learned that to reduce the y, they have to multiply the output by, we didn't discuss it so much because you already know this as teachers. So I have to maybe make the y a little bit smaller. So maybe 0.5, right? Okay, so almost, right? Or maybe if I want to be more accurate, of course, I can be as accurate as I can, maybe a little bit smaller to make this curve lower, a little bit lower. So maybe 0.4, too much. So what is between 0.4 and 0.5? Maybe I can do 0.45. Maybe this is good enough. Of course, you can be as accurate as you want if you have time. But for the sake of time, let's accept this. And sometimes it's really easy. It's really difficult to trace. So maybe let's cheat a little bit. So that took over the very small space. So let's make this a little thicker. Next, I want to cut the function from here to here. So what is the concept that they know there? They know about, or they have to know about domain. So this is from negative, maybe negative 4 point something, 4.7, negative 4.6. So maybe from negative 4.6 up to somewhere here, negative 1.9, negative 1.8. Let's say negative 1.9, for example. Okay. Maybe we can make it a little to the right, no? Can add a little to the right, maybe 1.8. Or maybe even 1.7. Okay. Or maybe even 1.6. So of course we can do that. We can be as accurate as possible. Students have time when doing this. These are high school students, so they have plenty of time. Okay, and then what if I want to remove the label? No, I don't want some labels if they are not needed, so I can just, so you can right click to remove the label. Next, I'll do the same for this function here. We have some okay. I'll read the comments later. What if I'll have another function here? So maybe I can start again for the students, so to further solidify their understanding. I can start again with x squared. So this time I'm moving to the right by 2 units, meaning this is plus 2 goes to the left, meaning minus 2 goes to the right. No? So I can have minus 2 squared. Okay. And then again, I have to lower down the curve here. Maybe I can just copy this one. So maybe they are symmetric. Okay, so good, right? 0.45, 0.46. Let's say 0.45 to make it the same. And then I can thicken it again to 7 and then cut the function. So the student who knows about symmetry will just look at this like, oh, so this is negative 4.7 to 1.7. So if this is symmetric, maybe I can just reverse this and make it positive. So that is the student who knows symmetry. So maybe 1.7 to 4.7. Okay, but not quite, right? So it's a little over over the image. So meaning I have to maybe 4.6, subtract a little bit, still protruding a little bit. So maybe 4.5. Oh, now it's shorter. 4.55 maybe. Good enough. Okay. So in telling the students, in guiding them, they are actually reviewing what they have learned earlier. No? So in the slides, the earlier slides, they learned scaling and also vertical and horizontal translation. Right? So of course you can use other functions, not just quadratic. Like for example, what is the function that the shape is like this? Somewhere here. Could be cosine, right? So if you type cosine, like let's say h of x equals cosine x, I only have 16 minutes. I finish at 10:20 or okay, so still same principle. Oh, the height is like half. So vertical scaling by half. So maybe I can put 0.5. Okay. But I have to, this is not connecting. So maybe I have to add a little bit. So 0.2 maybe, too much. 0.1. It's connecting, but still it's over it's inside the image. So maybe I can make this smaller, 0.45, 0.4, still over, 0.35. Okay. So I think it's very hard to estimate because it's not really a sin x, I think. But of course you can spend as much time as you can. But you can also accept it as it is. If you make the image smaller, actually it's not so it cannot be seen already. So from here, it's obvious that the domain is from negative. If the students know the meaning of domain, he can easily see that this is actually from negative 1.7 to 1.7 because these two ended, this one ended in the right bound here is negative 1.7 and the left bound here is 1.7. So he can just say, so the domain is from negative 7, negative 1.7. 1.7. Okay. So I think you get the idea, right? You get the idea. Okay, so there are cases that the students cannot use functions. So for example, this one. Of course, if the students are advanced enough, then maybe they can create a circle and just create a semicircle and just adjust the domain. But there are students, for example, they haven't solved radicals yet. They haven't learned about radicals. So we also allow them to use tools, though. So to mix them. So for example, here you can use the circumcircular arc. Okay. Okay. So for this, the advanced students can just create a circle, for example, and then create a semicircle, and then just limit the domains from here, from maybe from 2 point something, 2.6 to 4, for example, 4.1. So they can do that, advanced students, but some students, for example, grade 7, grade 8, they haven't learned radical equations yet. So they cannot solve, and they don't know square root, so they cannot have the square root of, they cannot use square root yet. So they can, okay? Okay, so I have 13 minutes. I think you get the idea, and I don't need to finish. There is a video for this that is from the start to finish. So I can give you the link later. But I think you get the point that this is what the students do when they are doing function art. So insert the image, use functions. In some cases, very small cases, maybe 5%, they draw directly without the image. So these are probably the artists, the ones that are very good in art. So they draw directly using functions, using curves, but it's very hard, I think, for many students. Okay. So learning outcomes based on my research. Function arts may depend conceptual understanding of functions, notation, and transformations. By the way, I will give you this PowerPoint and this links to the paper. So for example, this one, if you click on that, it links to the paper from School Science and Mathematics. So this is the paper. This is open access, so you can read them. You can read all the papers here. They are all open access. We will give you a copy of the PowerPoint. Apply functions as mathematical elements in constructing visual outputs. Develop fluency and flexibility. So if you are familiar with the Torrance tests of creative thinking, I have developed a framework, a rubric based on it, and I have written one paper about it. How do you assess the student's artwork? Because the good thing, if they know, is how do you assess? How do you put a score in each of the artwork, right? So you have to have some basis. And I've written papers about it, 2 papers. Demonstrate originality through strategic use of symmetry, transformations, and combinations. Persevere in problem solving when navigating technical challenges. So of course they encounter hardships when they create their artwork, and learn to price market. So this is a very interesting study. In one of the schools, I collaborated with many schools, more than 10 schools. And in one of the schools, the teacher suggested to the students, why don't we sell your artwork? So this is one of the sample artworks. Very, very nice. I think more than 700 functions for this one, if I remember right. Why don't we sell your artwork, for example? And then the students sold their artwork. And this is the paper about it. So out of the 179 participants in that study, 165 attempted to sell and 159 succeeded. And some of them sold 2 artworks and 3 artworks. And they actually, this is one example of what they do is they actually print it in a really nice paper and frame it. So this one was sold for 4,500 pesos. I don't know that's how much is it in Indonesian currency, but in terms of dollars, for example, I think $1 is around 50 pesos. So you divide this by 50. So meaning $100 is like 5,000. So this is like $500. No, $1 is 5,000. $100 is 5,000. So this is almost $100, maybe 90. So $90. So it's not bad. Actually, it's nice for the student. No. So this is also part of the outputs of my dissertation, and you can read them again in the. So how do you practical tips for implementation for those who want to do function art? What I observe is that some artistic students are not very good at math, and some math students are not very good in art. So although most of the students they did their artwork individually, but you can actually pair students, the one who are good in art and the one who are good in mathematics. 2, allocate sufficient time for iterative design and refinement. So what we do is we actually give the students 1 month to create their artwork, because usually they cannot do this within the class. So I give them a webinar on a Saturday, usually in collaboration with the teacher, and then they do the artwork outside their class. So you really need to give them time. 3rd, encourage students to select artwork that enables them to use multiple functions. What is the reason for this? Because for the students, some students, they just use straight lines for their artwork just to get away with other functions. So they choose an artwork that's purely straight lines, composed of straight lines. So they just use linear function. Okay. 3rd is ensure ethical use of reference in images. So we want them to use that are images that are not copyrighted. Better if they're original images. Emphasize the use of functions and their transformations over the use of geometric objects. Now, some students, if you tell them, oh, you can use at least 10 functions, they just use 10 functions and then use geometric objects for everything. So you have to encourage them. We have to encourage them to use as many functions as you can, and then provide checkpoints and feedback throughout the creation process. Meaning, you have to check, like after a week, one of the teachers, after a week, they check the outputs, and then after another week, check again and make suggestions, and so on and so forth. So the outputs of that class is better compared to the teacher who did not check. These are some of the quotation of the students. I won't read them, and we don't have a lot of time, but it is in the PowerPoint. And here are some of the outputs. So you can see the number of functions that they use, 75. So it's quite complicated, but of course, some students just choose few. This is 45 functions, grade 11, grade 9 choose 139 functions. And then 25 functions, 17 functions, 70 functions, 40 functions, 114 functions. So maybe I'll give you the actual, I'll click this one, so I'll give you the actual artwork. I think it's a different, maybe this one. I think the link is wrong for the first one. Okay, so you can see, I think I mixed up the link, but you can see the artwork that some of the functions that they use. So if you go to Classic, so that it's easy to see the functions, because GeoGebra sometimes doesn't round off. So these are the functions that the students use. You can group actually the objects into object type so that the functions are together. And you can check which of these are functions. So for example, if I click this, if I color them red, these are the functions and the others are not function. So this is the conic circle, for example. And the others, for example, maybe line segments. So they are not all functions, but it's quite a lot. The student used quite a lot of functions for this. So from here, the students use 40 functions. But in some cases, the students really use a lot of functions, like some cases 1,000, 700, 500. Here are some also. This one, very few, but because the drawing is very simple. So here, 210 functions, for example. This is the national hero of the Philippines, Jose Rizal. I don't know if you know him. So this is 192 functions. So that's a lot. So recently we have a competition. I don't know if you heard of it. There is a competition sponsored by Simeo STEMED. And these are the winners. So these are some of the entries, the finalists, and we have the winners. And the winner got like $300 and then $200 and $100 for first, second, and third, respectively. So we also have local competition here for the second Philippine International School in Riyadh. And these are the winners, really, really complicated artworks. This one has, I guess, 700 functions. Right? And if you go to the Facebook page of GeoGebra Institute of Manila, you can search it on Facebook. You can see a lot of artworks from the students. So we will, of course, you can just search this easily. You will have the PowerPoint. You can search it later. And here are some of the publications. I also listed them here. There are, of course, links. And of course, you can go to my GeoGebra profile. So there are 6 articles in Q1 journals. And I don't know if you know Thinking Skills and Creativity. It's a really, really good journal. I was able to publish one paper there on function art. So there are a lot of Q1 and Q2 papers and some SSCI journal papers on function art. And there are other coming soon within the year, maybe 3 or 4. And there are still like around 10 which are under review. So hopefully next year I will be able to publish all of them. And here is my GeoGebra profile. I don't know if you are following it. This is some of my GeoGebra is very, very, I told you earlier, it's very powerful. So these are some of the models that I created. So many of them, more than 500, I think more than 500 models. Like this is the umbrella I think that you saw earlier, so you can actually animate. So it's not just function art. I do a lot of GeoGebra. So if you want to invite me later to talk about GeoGebra, I can also do it. So this was, I just did this last week, I think, last week, 2 weeks ago. So this is the Viviani's curve. And for the last one, I don't know if you saw earlier the Taj Mahal. So I also created this using GeoGebra. And I have a printout of this here. I can't can be seen, but you know, this is a 3D. How can I do it? It's hard. Okay, so this one. Okay. So it's 3D printed. So you can actually, if you have a GeoGebra 3D shape, 3D model, if you do it correctly, you can export it and 3D print it directly. You don't need to put it in another software like Tinkercad. So you can, if you do it correctly, and you can also do something like a demonstration of some you know, mathematical theorems, for example, or for the kids, or something like that. So you can go to my profile and you can explore. There are a lot more than maybe 500 applets. I can put it in the chat. So I work a lot on GeoGebra, higher mathematics, elementary school mathematics, 3D modeling, art. So you can check my profile. There's a lot. And sometimes I just draw whatever I see. This is here in Linz. This is near the restaurant, and I saw it and I draw it. So it's not just function art. I do a lot of GeoGebra stuff. I think that's it. Let me go back. Let me see if I forget something. So that's it. And we also have a guidebook. This is the support materials for the students. So they have if they want to practice, for example, after the webinar, so they have this. This is what's on the PowerPoint. We also give them the PowerPoint. And we have the cutting, how to cut functions here. And we also have creating the artwork, like how do you color. Aside from this, you can also use polygons for creating the colors and so on. So there are so many. And the videos also. The shortened webinar is here. So the students can rewatch it if they want. That's all. So I created a lot of support materials for the students, and they've done a lot. Like I'll show you briefly. I know I'm 3 minutes over time, but I can show you some of the artworks. Student function art, and there are so many. For example, so many artworks that I haven't shown you. I think I have more than 700 of this, and the students even created also 3D models. So I haven't shown this yet to anyone. All right, that's it. Thank you very much. I hope you have learned something, and I hope you can also do function art in your class. If you're teaching, just email me and let's see what we can do.
Okay, thank you very much, Dr. Bautista. Such a magnificent, brilliant, and eye-opening presentation. It's a truly breathtaking to see how rigid mathematical function can turn into a beautiful work of art through GeoGebra and STEAM integration. So you have shown us that mathematics is not just about numbers, but also can create the creativity and beauty to see how mathematics, art, and technology can be beautifully and harmoniously integrated through and function art and GeoGebra. All right, ladies and gentlemen, we are now opening the Q&A session. If you have any question for Dr. Bautista, please feel free to use this Zoom chat box to type your question. So basically, we have like a first question, Dr. Bautista. The first question is from Mr. Shaifu. It's such an interesting question. So the first question is, what will the image of the algebraic and tertiary function show earlier looks like if they were added together? And the second one, what would the graphic illustration of the function be like if they were transformed into a binary numbers? We would like to hear your thoughts about this, Mr.
Sorry, I didn't understand the question. Can you speak slowly? The first question first. Now I can't hear you. I think you're on mute.
Basically, you can read it on the chat box.
Oh, really? It's here.
Oh,
Yes,
yes,
Dr.
yes.
Guru. Yeah, in the chat box. Yeah,
Chat
I think
box.
it's better. Yeah, because the signal is not quite good.
What would the image of algebraic and tertiary functions shown earlier look like if they were added together? And what would the graphic illustration of the functions be like if they were transformed into binary numbers? Huh. I don't exactly know what do you want to, I mean, the meaning of the question. I have shown you many examples of how really our actual artworks are, and I can still show you a lot if you want. And for the second, what would the graphic illustration of functions be like if they were transformed into binary numbers? I I didn't get it actually. I so sorry. Maybe you can rephrase it.
Or we can call Mr. Saiful Bahri. Boleh pakai bahasa
Yeah.
Indonesia. I just offer to just use Indonesian, then
Yes,
I
yes, please.
will help.
Yeah, yes, please.
But I don't think so. Still there.
Is still here?
Bahasa sah. Mr. Saiful.
Mr. Saiful, are you here? Masih di ruang Zoom? Sebentar. Yes, he's still in a Zoom meeting, sir.
Okay, so maybe he can talk or maybe we can.
Kalau enggak, lanjut aja. Saya ada pertanyaan.
Okay, maybe we should move to the next question. We have question from Farida Nurhasana. So maybe you can deliver your question, please.
Okay, thank you. Thank you very much, Guillermo, for the very magnificent presentation. Yeah, you have very massive GeoGebra applets, yeah, more than 700 guess, yeah. Okay, Guillermo, as that you presented so many artwork using the function did by students from grade
Yes.
9, 11, and many more. Actually, in GeoGebra, we can use two strategies, just like you also presented. And the first one, actually, the students can use the tools. Yeah, use the tools, and then the GeoGebra will show what the function about they created there. Yeah, in the panel, right? But the second one, probably for students who are learn about for example, in higher education here, a student in higher education, they learn about function in calculus. So various function in calculus, right?
Yes.
And then so they have a very strong basic knowledge about the type of function, and then how the what we call is how the characteristic of each function. So the preference of using so many function is greater than the students in junior high school or senior high school. So
Yes,
did you always use the approach using tools first, And then after that, the teacher will explain about that function or that kind of a function. For example, when you demonstrated the apple, right? The apple,
Yes, yes.
yeah. The students in junior high school, they haven't learned about the equation of a circle. No, they
Mhm.
didn't learn yet about that. Okay, and many
Yeah.
various functions. Mostly only linear function. And in
Mhm.
the grade 11, I think they started to learn about the quadratic function.
Yes,
So,
yes.
um, what are the strategy that should be used by the teachers in order to making a bridge for this situation, and then how to explain to the student the various type of function which are they haven't learned, they never learned before, but they use it in GeoGebra, and then vice versa. Thank you.
Okay, okay. So first of all, we try to encourage them to use the functions that they have learned. So if let me check if I can show you. For example, most of the grade 8 students, they just learn about linear functions. So most of their drawing actually are straight line segments, for example. So these are examples of the grade 8. And if you look at their artworks, they are like mostly straight lines. Very few of them use. Of course, we cannot prevent them from learning other functions because they can just learn it on YouTube. But we usually just say we do not force them to use functions that they haven't learned. So, for example, this is just from grade 8, and if you look at the functions that he or she used, well, these are straight line, and obviously these are linear functions. So some of the yellow part is the polygon. That's why you have the segment, and of course the vertical part. The vertical segment, of course, it's not a function. But as you can see here, all the functions that are possible, if I color them red, for example, these are all functions. These are all linear functions. Okay, so meaning for the first year of, I call it first year because we call it that year before. But for grade 8, they can just use linear function and they can already do a lot of beautiful artworks. So most of the grade 8 students, for example, they just use linear function. So they are like straight lines. So most of them are straight lines, straight lines, straight lines. These are straight lines. They just really know how to color it. For example, this one is straight lines. These are just nothing but straight lines. Okay, so made of straight lines. For the circle, for example, they can still use if they really need a circle for the eyes, for example, they can of course use the tools for the eyes, no? And they can use, of course, other tools. But what we tell them is we encourage them to use as many functions they can whenever possible. No? But of course, these are high school students. Sometimes they follow, sometimes they don't. But of course, for advanced students, you have a lot more. They know a lot more. Like for example, advanced students know parametric equations, for example. So they can just use parametric equations, for example, for their art. And a lot of calculus, they can use derivative maybe or whatever. For example, for coloring, they can use the command integral between. So for instead of so I think it's on the condition like, oh, if you have more functions, then I'll have your grade. You have a better grade. Then the students they use like 400, 300 functions just to get good grade. Then, these students, they are very competitive with their classmates. So if you tell them that they get good grades if they have more functions, then they use more functions. I hope that I answered the question.
Thank you very much. Actually, it's remind me. I think
Mhm.
it's about 2 years ago. I did um I did a GeoGebra to paint a batik. Do you know batik? And I
Yes, yes.
presented in one of the event in Surakarta city.
Mhm.
This event is intended only by the artists.
Yeah.
So I used GeoGebra sketch the batik pattern.
Mhm.
Yeah,
Yes.
yeah, still remain. Thank you very much, Guillermo,
You're
for
welcome. And
very
it also
interesting.
depends on the goal. What is the goal of the activity? So my goal is for students to learn functions. So I want as much as possible. I want them to use functions. But of course, some students they just they don't care. If you say 10, they just put 10 and then the others. They have very complicated drawing and then you just put 10 functions. So
But I think it's also can be used as a constraint in STEM approach, right?
yes.
Yeah.
Constraint is
So yeah,
important.
we can put the constraint. For example, you can only use linear and quadratic only, for
Yes.
example, like that one. But the
Possible.
students also can use, for example, the quadratic function, which is open up and then open down and then to,
Mm.
yeah, just like open to the left and then open to the right, just like that. So all the combinations should be there, just like this.
Yes.
Yeah. So there's so many more ideas, I mean, based on your presentation. Yeah. We hope that we can collaborate next in the futures.
Of course.
Thank you.
Yeah, the constraints is very important. And I have one teacher in the Philippines. It's like a special school, like for the smart students. He only let the students use inverse functions. So I said that is too much, but students were able to do it. So so uh, the reason, well, technically, I mean, ideally, function art should be exclusively functions. But of course, not students are very smart. I mean, they have different levels. So just to accommodate the students, just to make them happy. At first, you have to make them happy for them to be able to learn. So okay, you can use segment if you want, but do not just create an artwork that is purely assignment, then that is not function art. So something like that. So thank you. There's
Thank
another one,
you.
I think, in the comment.
I think we have I think the last questions because we have limited time, Mr. So the second one is maybe the first question. When creating function art, do students focus more on visual explorations or mathematical reasoning? And the second one is this activity accessible for students with different levels of mathematical ability? Maybe you can
Yeah,
share.
yes. So for the first one, I think they do both, no? Although the mathematical reasoning part is still, I have some evidence from the papers, but not so much. So I think we have to really have a maybe pre-test, post-test, or more interviews. I have a lot of interviews, but I haven't processed them yet. So we have to write a paper that really it's mathematical reasoning, because you can't just say, oh, the students created this, the students created symmetry, they do mathematical reasoning. Maybe they're just looking at the patterns, but they don't really understand. So we have to explore that. It's part of my list of exploration later on. And can this activity be accessible to students with different? Yes. From my experience, even students with the low ability, they can also do it. Of course, not as much, not as not as many functions as those who are very good in math. But still, I think it's accessible because I've implemented it in different levels, like even the slow ability. In some sections, for example, they just put really small number of functions, like the minimum. So I do not know if they don't have the ability, they are having a hard time, or it's just that they don't want to do it. So those are the things that I also want to explore. So it would be good to implement it in Indonesia also.
Okay,
Thank you.
thank you so much. I think that's the last questions that we have for today.
Mhm.
So thank you so much, Dr. Bautista, for those wonderful, inspiring. And before we officially conclude our session today, we would highly appreciate if you could share some final remarks or closing statement for all the participants in this room, especially for our mathematics teacher and master student here. So if you can share your little bit thoughts about it to close this event, sir. Can you please give us a closing statement for this event, sir?
Oh, is it me?
Yes.
Okay. I didn't. Okay, so I think the idea is, I think what I've learned from my study. I've been doing this with teachers for 3 years, and I think Indonesia and the Philippines, we have very, I think, very similar culture. When I started function art, actually the teachers didn't believe that the students would be able to do it. So I said, give me 2 hours and I will do the webinar and let's see what happens. So I think the gist is, maybe we just have to try first, because I think I cannot speak for all the teachers in my country, but sometimes they don't believe that the students can do it. But I think the students are very creative. We just have to give them the environment to be creative. Sometimes we limit them too much with what to do, like we dictate them what to do. But if you give them a little room to wiggle, then I think the students are very, very creative. And that is, I think, that is our responsibility as teachers, to let our students be creative, to let them think, not dictate, well, not dictate too much, so that they can come up with the original ideas. And later these students, they will become teachers, they will become scientists, no? And you cannot have a scientist if you don't dictate, you have to do this, you have to do that. You have to let them think on their own and make mistakes. It's fine. It's part of the process. I think that's all. Thank you.
Okay, thank you so much, Dr. Bautista, for those wonderful, inspiring, and meaningful closing words. So it has been absolute honor and a privilege to have you as our distinguished speaker. We wish you all the best in the future research at Johannes Kepler University and your upcoming international project. We sincerely hope this is not our last meeting, and we look forward to collaborating with you again in the
Yes,
future.
yes.
Thank you very much, Doc. So with that, we have come an end of the entire webinar series program. So, and of course, we would like to extend our highest appreciation and deepest gratitude to all the wonderful webinar participants this afternoon. Thank you so much for taking time to join us, for showing such a great enthusiasm, and for asking such thoughtful and substantive questions. As a reminder, a certificate will be sent to the participant and the link will be sent into WhatsApp number. So wait until our committee send you in the WhatsApp. So in the end, as the MC and moderator, I apologize for any shortcoming technical issues or mistake in the wording while guiding this event. May the knowledge we have gained today bringing blessing and progress to equality mathematics education in Indonesia. Thank you very much for your wonderful attention, everyone. Good afternoon and have a pleasant rest of your day. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. See you at the next web series. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Bye-bye. Thank you.
Thank you very
Thank you very
much.
much.
Thank you.
Thank you very much.